I'd like to first talk about PRRS, and I'm going to move through this pretty quickly, the PRRS portion, because I'm sure there's a lot of you more interested in the PED portion. But we're going to cover some basic information. Not knowing exactly the audience, we'll start with the basic and hopefully have enough time to ask a few questions at the end. So we'll move through this fairly quickly on some of the PRRS. So we'll talk about the distribution across the U.S., virus characteristics, clinical signs that you will see typical of disease, testing that can be done, as well as the spread of the disease, stability of the virus, and control and elimination. Additionally, we're going to talk some about prevention. So I'd like to spend a significant amount of time at the end doing that. So PRRS, porcine reproductive and respiratory syndrome. Been around for a while, so we're going to go through these topics on PRRS. What are some of the characteristics? Well, it may not mean a lot to you, but PRRS is an enveloped RNA virus. And that's significant because the fact that it's an RNA virus means it can change rapidly. It's enveloped, meaning, at least for you, it means that it's less stable in its environment. Pigs infected with PRRS have long-term viremia. So pigs can maintain that virus in their blood before they clear it for upwards of 3 weeks. Some are persistent infections. So they can hold that virus and keep it alive, and it can recrudesce or come back up with it for up to 157 days post-infection. So that's pretty significant. You can have an animal that looks healthy, looks clean, 157 days later, it can still be shedding virus. So there are differences in PRRS strains additionally. So there's differences in the virulence, meaning how much that virus affects the pig. Some are very mild, and some cause a lot of clinical signs. PRRS is highly infective. It only takes about 10 virus particles, which are too small to be seen. The flip side of that is it's very slow moving within a herd. You can have a herd that's infected, and it can be just an ongoing process of moving from sow to sow. Slowly, there can be maintained pockets that are not infected, and so you just have a perpetual problem. So for the PRRS virus, there's also a short duration of immunity. So due to the fact that it's RNA, which we talked about, it mutates a lot, it changes, and the pig doesn't recognize it anymore. Their immune system doesn't. So they can perpetually be going through PRRS struggles if new strains of that virus are introduced, or if there's enough mutations within the herd. So further characteristics, colostral immunity. So that immunity that piglet gets from the sow, that first milk, is very short-lived. So pigs will become infected typically prior to weaning. It replicates and multiplies in the lungs primarily. That's why it's called a respiratory disease. Luckily, this virus is very sensitive outside of its host. It's very fragile. Further, it replicates actually in the immune cells within the lungs. This sets the lungs up for further bacterial challenge. So as you know, PRRS usually isn't what kills the growing pig. It's the secondary bacteria that are left to just grow, uncontrolled. The defense mechanisms of the lungs are impaired, and in the end, we have an increased risk of secondary infections. In the breeding herd, what do we see? Well, we can see late-term abortions. That's what PRRS is classic for doing. You can see stillborns, mummies, and weak-born piglets. It's very common to see an elevation in pre-wean mortality and also an elevation in sow deaths. And all this combined leads to a decreased farrowing rate, loss of pregnancy, and that failure to conceive. In the growing pigs, what do we see? Well, it's primarily a respiratory disease, as I mentioned. You'll see, in severe cases, those pigs that are thumping, feverish. They could have a lack of cough and uncomplicated PRRS. You'll see elevations in mortality, reductions in average daily gain, and poor feed conversion. All this leads to less money coming back into your pocket from those same pigs. We'll also see an increased level of coals, pigs that don't grow as well, and reduced full value pigs. So what can we do from a testing standpoint? Well, to test for the virus itself, we can do what's called a PCR, polymerase chain reaction. That can be done from drawing a blood sample and sending that in. It can be done from oral fluids. There's also immunohistochemistry, which very simply means when your veterinarian sends in a sample to the diagnostic lab from a pig that's died, they can slice that, put it under the microscope, put special stains on it to show that virus in those tissues. We can also test for previous infection. So those pigs that have gone ahead and cleared the virus and are back healthy again, their immune cells in their body produce antibodies, which we can test in the blood. And it can also be tested in the oral fluids. How does it spread? What are the routes of infection? Well, the primary one is animal contact. That's primarily through new animals being introduced into our herds. That's why we like to have a quarantine and an isolation period, ideally. It can also come through fomites, or objects that we bring into the farm that have that virus on it. So our clothing, boots, tools, and equipment can all carry the virus. What else? Well, we have semen. So if your bore stud breaks, you're introducing that semen untested, don't know about it, your herd can very quickly become positive. Also, there are studies showing it's airborne in nature, meaning the wind's blowing right with the right conditions, you can get it from your neighbor, you can pick it up from the truck passing by. It makes it kind of devastating to try and control, and that's why a lot of farms up in southern Minnesota and northern Iowa have started filtering. Again, that's not a foolproof method, but can help control. So, as we go along, I'll compare some of these, but just for now, we'll look at PRRS virus at about 98 to 100 degrees Fahrenheit will survive for, studies have shown, between 3 to 24 hours, which is a relatively short period of time, as you'll see later. At a higher temperature, so somewhere approximately 132 degrees Fahrenheit, it only lasts for between 6 and 20 minutes. So again, relatively short. Disinfections, this virus is also very susceptible to disinfection. Our standard disinfectants work, including bleach solution, Synergize, Vircon, and others. Also, any combination of these efforts, including cleaning an item, disinfecting it, giving it downtime, and baking it, have really worked very well to control PRRS spread. So biosecurity also becomes key when you think about this whole circle. So control and elimination. We're not going to go into a lot of detail on this. That's probably a further discussion for your veterinarian, but just very briefly, the strategies include a complete depopulation of the premises, cleaning, and then a repopulation with clean animals. A closure of the herd where you have some way to acclimate those animals to the same strain of PRRS virus, get them on the same immune health level, close the herd to new entries for a period of time, usually 30 to 35 weeks, so it has to be fairly long, due to the slow nature of PRRS moving, and then opening the herd back up has been shown to be effective. Some will take a wait-and-see approach additionally. Sometimes that goes well, and sometimes that doesn't go very well. So there's other ways we can stimulate immunity, and some of those are listed in the tools here. We can homogenize a population by doing feedback material, by inoculating those animals, and also using vaccine strategies. So, how do we prevent PRRS spread? Well, really, I think there's three good ways in my mind to prevent an entry into your farm. Biosecurity, biosecurity, and biosecurity. We can use vaccine strategies. Those can help if you get something in, but due to the changing nature of the virus, there's no way to truly protect those pigs against that entry, and so really you have to just prevent it from getting in, period. So, moving on to PEDV, which I'm sure you're all a little more interested in hearing about than PRRS. So, PEDV, it's kind of a newcomer to our ball game, isn't it? It's not a newcomer, though, on the world stage. And in 1971, there was this diarrhea found, an epidemic diarrhea of finishing pigs in England. In 1976, that was found in all ages of pigs in the UK, and by 1979 there were many European countries that had this epidemic diarrhea. During the 80s and 90s, we saw further spread into some of the Asian countries, Japan, Korea, and China. Additionally, moving through the early 2000s, PED moves through other countries in Asia, and in 2010 and 2012, there was a strain of PEDV that caused a lot of problems in China. It was really very devastating to the industry. And in May of this last year, May 16th, the National Veterinary Services Laboratory confirmed that we had PEDV in the United States. And the real kicker for us is that this strain was 99.4% similar to the one in China that was very devastating. We didn't happen to get lucky and get a more mild strain similar to what had circulated in Europe. This slide, the next few slides just very briefly talk about kind of the history of some of the diagnostics in this country. That first case actually dates back to mid-April, but wasn't found or identified. The cause was not identified until May. But you can see this is a cumulative total of all of the cases submitted up until mid-July, early July. And here's a week-by-week total of those cases. Keep that in mind. It looks like it really grew rapidly, didn't it? Now this apparently is not going to show up very well for you. I apologize. Some of those colors. But you can see this covers the same time frame up until that early July. And these are new cases reported. So that's that blue line you saw in the last graph. Since then, and especially as colder weather came on, we've seen a huge spike in the number of cases submitted each week. So we thought that it was moving very rapidly in the summer last summer, and that has really only accelerated as we got into cooler weather, which really would be more typical of what we see with TGE. So this shows kind of that same thing, but goes back and shows the cumulative cases. So we're well over 2,000 cases that have been submitted, and tested positive in 23 states in the United States. So if you think about the major pork producing states, that's pretty much all of them and then some. So again, early August, I haven't seen a more recent number, but in early August, so dating back to kind of this time frame, the National Pork Board at one of their industry meetings in Des Moines saw they had estimated approximately 250,000 sows were affected in the U.S. And they therefore extrapolated and estimated that that would mean a loss of 1 million market pigs. Again, that's dating back to this time frame, and since then, here are the positive cases by farm type in the U.S. And we've seen that that's only grown. So how long has it been here? We've mentioned that. Fecal samples dating back to mid-April. What ISU did with some of their diagnostic samples, they went ahead and tested fecal samples from previous submissions going clear back into December. None of those tested positive, and so we really believe that this is the index case in the U.S. So it looks like it was not circulating for very long at all in the growing herd before we got it into our sow farms. So what are some of the virus characteristics? So this is a coronavirus, and it's called a corona because on electron microscope it looks kind of like a crown. That's how it's given the name. There are other coronas, including TGE as a related virus. There are also respiratory porcine coronaviruses, which have not been that significant in our industry. There are also bovine coronaviruses, and lots of other species have their version. Incubation time for this was initially estimated at somewhere between 12 and 72 hours. It looks like if you get it into your farm, you will know within about 24 hours. It will become obvious to you, especially in a sow farm, I should say. So this makes for easy tracking, I guess, and you know when it started, but not very helpful, though. So what are some other characteristics of this virus? Well, this virus is a fecal-oral virus, meaning just that. It's passed in the feces and picked up orally by the next pig, and the cycle continues. Luckily for us, this is not a zoonotic virus, meaning this is very pig specific. You and I cannot get sick from this virus. It doesn't affect people, and it's not a food safety concern. Also, very luckily for us, this is not an import or export issue. It's not a reportable disease in the United States, and so it also doesn't limit any interstate movement or export out of this country. Also not considered a foreign animal disease by the United States. Alright, another characteristic that's very important to know about this is it has extremely high replication, meaning we take a very small amount and the pig gets sick and they shed or kick out a very high amount. Some have said that's in the range of 10 to the 8th or 10 to the 9th per gram of feces. A gram of feces is 1/28th of an ounce. So not very much. And 10 to the 8th or 10 to the 9th, we're talking about 10 to the 6th is a million. So it's 100 to 1,000 times higher than that. So roughly a billion per 1/28th of an ounce of feces. There's a lot of it. So just as a quick scenario, if I have a disinfectant that will kill 99.99% of the virus and I use it, if I only have a gram of feces, that still leaves me there's somewhere around 100 viral particles required to cause disease in the pig. That's the estimate anyway. And so as a result, doing that, I will still have 100 times the amount of virus needed to infect a pig, if I could split that out. So that's a very effective disinfectant. That's not a lot of feces. I could still spread that out if I could and get 100 pigs sick. And that's kind of illustrates how this has moved so quickly through our industry. Here's some images. They're kind of industry images that were circulated early as this came to the United States. We're going to talk a little bit about the clinical signs of this disease. So clearly, as the name implies, it's a diarrhea. You'll see very quickly very wet and dirty little pigs. They very quickly, especially young piglets, will rail up. It's not uncommon for them to be seeking warmth by climbing up and laying on the sow. I've seen that several times personally, and they really just deteriorate quickly. And this picture in the lower left-hand corner is one of the ones that was circulated early amongst veterinarians, and this is, I think, a 5,000 head unit, and these are the piglets. They took 2 or 3 truckloads like this out in the first day or two, and so it really can be very devastating. The severity is very dependent on the age of the pig as well. So sows in gestation who get ill, you'll see some sows off feed, you'll see vomiting, you'll see scouring, and in some cases you'll see a low level of abortions. The sow just feels that sick. In the breeding barn, 24 to 48 hours post-infection, you'll see much of the same. You'll see sows off feed, vomiting. Vomiting is a very telltale sign for this disease. TGE can cause vomiting, and PED causes vomiting. And other than the one-off vomitoxin or something like that, there aren't a lot of other things that cause a sow to vomit. So, again, some of the early industry report survivability being 0 for the first couple weeks of piglets being born. Week 3, if you're saving them, you may have 25% that will survive, and that's about 3 weeks post-up feedback to give the sow some immunity. Week 4, 5, and 6, it increases to 100%. That's kind of I hate to say it, but kind of an ideal picture. There are some farms that have maintained a level of loss of 2 to 3 times their normal pre-farrow losses, pre-weaning losses, in the farrowing house. And that's they just haven't come back down like they should. So, continued mortality for 7+ days, we talked about that. In the nursery and finisher, and the first case in the U.S. was actually a nursery case, and you'll see a high number of pigs affected with a scour. They really thought it looked like a rotavirus or something hitting those pigs hard early in the nursery, or E. coli. The mortality is typically very low compared to what it is in the farrowing house. can be in that 1 to 3%, maybe a bit higher depending on your situation and the comfort level of the pigs. In finishing, you can miss it. So if you have a good healthy set of pigs in late finishing, somewhere mid to late finishing, you can see it as a very transient diarrhea. Some here, some there. If you have other enteric challenges, it may manifest itself more severely, but in some cases it can be missed. And some of those challenges that might cause it to be more severe, both the enteric issues or gut issues those pigs may be facing, but also PRRS, PCV, and SIV, something else viral that challenges the immune system, can really cause your problems. So really this disease looks a lot like TGE. There are some who've given the descriptor of this looks like TGE but on steroids. And most all pigs are affected will have diarrhea. So here's the comparison of that chart we kind of showed a little bit before. Compare a few viruses. So we see antibacteria, I guess. Age affected, both TGE and PEDV affect all ages of pigs, all classes of swine, compared to a rotavirus or an ileitis. And the number affected, given time, it'll be nearly all in both TGE and PEDV, but can be very variable in both a rotavirus and an ileitis. Clinical signs, diarrhea in all those. Watery diarrhea, more so in the TGE and PEDV, less so in rotavirus and ileitis. And vomiting, again, those are the telltale signs of watery diarrhea and vomiting. And it moves quickly through your herd. So again, that profuse watery diarrhea and vomiting are the main clinical signs. So how does it do it? Being a veterinarian, I have to share this just a little bit. Here are the lesions that we see. In the pig's gut, you have the tube-like structure, which is the intestine up here. And those intestines have these finger-like projections sticking out into the space that allows for more surface area to absorb nutrients from the feeds. Well, what PED does is it mows those down. It essentially attacks those cells and kills them, and the pig sloughs all of those villi, those finger-like projections. So with the pig's inability to absorb things and continued loss of fluids through these villi that have been chopped off, you get a very watery diarrhea. So what might you see opening the pig? I apologize again, these pictures aren't real great on this projector, but may not look that different on the inside. If you're one that does your own necropsies or you watch the veterinarian, you'll see a very red and thin-looking intestine. Samples to submit. Your veterinarian will probably take 4 to 6 sections of those intestines to submit for sampling. Also, fecal samples are a good choice, very quickly and readily identified because there is so much in those intestines. So what testing can we do? Well, we can do a PCR test, which tests for the genetic material of the virus. That can be done on feces or on those guts that are submitted. Again, the histology, looking at that under the microscope, those intestines, as well as serology is now recently being developed, where we can test for the antibodies that the pig generates to this virus. That allows testing to be done with just a blood sample. Okay, how is this spreading? Well, there's a study done early that the National Pork Board funded, and they went in and they sampled a little under 700 trailers headed into and out of packing plants. And they chose 6 plants, and what they saw going in was about 17, this is early on, about 17% of those trailers were positive going in, and 27% of them were positive coming out. That's fairly significant. So what that tells us is that increased number of trailers contaminated coming into the plant leads to an increased number of trailers contaminated exiting the plant, and that packing plant or any other area where we commingle swine is a risk to our operations. So we need to be very careful in how we interact with those. Again, this also shows us that it's not untypical, especially in hog dense areas like Iowa, not to be washing trailers in between loads. That really tells us that we can multiply the number of trailers that are contaminated with each time they go through the plant, and your chances of bringing it back increase as well. Alright, so the stability. We talked about PRRS a little bit here in the right-hand column. PED, in comparison, it can be good at 100 degrees for 7 days, compared to TGE for 1 hour, and PRRS for 3 to 24 hours. PED at 140 degrees Fahrenheit can survive for up to 30 minutes. It's believed that 30 minutes is kind of the magic kill time, and that's a surface temperature of 140 degrees. So much more stable than is PRRS. Again, part of our problem. Luckily for us, most of our disinfectants do work. Again, disinfection only reduces the number and does not sterilize the surface. So we really need to rely on a combination of methods to remove this virus from equipment and facilities. Both cleaning to remove the big chunks, reduce that viral load and that fecal load initially. Disinfect, allow for either a downtime sufficient or a bake, if possible, to kill that. And again, probably our best weapon against this virus, similar to PRRS, is biosecurity. You really, let me tell you from first-hand experience that if you can keep it out, it's worth it. Alright, so control and elimination. One of the first questions I usually get asked is, are there any vaccines for this? The answer is yes, with the caveat that I don't know that any of them have been proven to be effective. They're expensive, not necessarily effective. Hopefully someone will develop a good one and they'll probably get rich off of it, but there are some that are available in this country, some that were previously available in China. Again, don't know that it's worth. Look at it very carefully and look at the promises very carefully before you spend a lot of money on a vaccine for this. Talk to your veterinarian. Medications. There's no medication you can give these pigs that will specifically help against the PED virus. Now, with that said, that for this, it may help with some of the secondary items. As you get the massive amount of undigested feed moving lower into the intestines, you can get some flare-ups of E. coli, potentially of a salmonella, and those would be benefited by an antibiotic. But again, talk to your veterinarian, understand what you might be working with before you go implementing some of those things. Alright, what other methods do we have? Well, to get immunity to a sow herd, we can feed them back this material and essentially make them all sick. That's not very palatable for most people. We'll talk about it in a little bit and why some are doing it. So, otherwise, what do we have? Again, similar to PRRS, biosecurity becomes that much more important than it did before this disease. Alright, so again, I'll jump back into control and elimination. So, some work in China showed that somewhere between 90 and 150 days of closing a herd can be very effective because it'll naturally spread around the herd. During that time, you may have some real peaks and valleys, or maybe just valleys and valleys in your production of wean pigs. And a lot have depended their timing or how long they close their herd based on their gilt supply. If they can load a bunch of gilts in to go ahead and become immune with the rest of their sow herd, they'll do that and they'll extend their closure. Some, because of gilt supply, and necessitate really only a 90-day closure. Longer is probably better, though, from my perspective. Now, it's also been suggested, it's been shown to be effective, that if you feed back the entire sow herd, you essentially lose several weeks of production, a couple weeks of production in there. You'll probably abort some sows. You'll have some return, and you'll probably reduce your conception rates early on. So those will come back as regular returns. And then you should, with good sanitation, a lot of cleaning efforts, be able to quickly come back up to close to full production. So, again, talk to your veterinarian before you launch into one of these efforts. But some of the things you'll see and what's been suggested is if you're doing this, go through and mark the sows that you know are sick. Are they off feed, vomiting? Do they have diarrhea? That'll help you understand how much immunity you gained within your sow herd. And if you have pigs that are questionable, you may want to redose those pigs. But again, probably more of an in-depth conversation with your veterinarian before you jump into anything like this. Alright. Again, who you ask is also probably important. We're still learning a lot on how to truly control this disease. It's gotten the best of us for the last 8 to 10 months. Okay, why feedback? We talked about that. It does increase the disease in that farm for a period of time. The idea, though, is to keep it from being a lingering illness, to try and get everyone on the same page, move past it, and get back to weaning some good pigs. It's really a tool to manage the immunity of the herd, build that colostral immunity so the piglets that are born, if they get colostrum, will actually live and be able to wean more pigs faster again. And it's really a goal to prevent long-term continual disease in the herd. So for PED, some of the need-to-know notes. Not a food safety, public health concern. That's crucial that we understand that our employees understand that if we have any, and that those that we interact with understand that. It's devastating to our pigs, but it's still safe to eat pork. Pork's as good today as it was 8 months ago. This is a very infectious and hardy virus, meaning it can last outside the pig for a long time, and it is also very damaging. And again, in my opinion, biosecurity is key. And I have a set of slides here on biosecurity that I'd like to run through. I know we don't have a ton of time. I'd like to make sure to have time for any questions you have and things that I didn't cover, since I couldn't make this an all-inclusive presentation in 45 minutes. But a few slides on this because I think it really is important. So what is biosecurity? I look at it as a process or a set of procedures to prevent or minimize disease. Minimize that risk that we have. So there's two main types as I think about it. There's internal biosecurity within my farm. How do I keep from spreading something from one group of pigs to another? That can be a nursery barn, that can be a finishing barn to another, that can be within inside the sow farm from farrowing to breeding or breeding to farrowing, vice versa. And both of those become important with PED and PRRS, but especially with PED. Why do I want to do it? Typically there is some cost in ease of doing business, in money, etc. for implementing biosecurity procedures. Now with that said, what we've just discussed about PED, I will tell you firsthand that there is a very real cost. Mortality, loss of production, increased labor. There's a lot of cleaning efforts that need to go into getting past PED. Increases in medications, vaccinations. And don't underestimate this bottom one, personal and worker morale. It's really hard to take someone that works in farrowing, where their sole job is to save pigs and keep them alive and put a good product out the door, to then have to be, most of their day is spent removing dead pigs. Is not a fun process. And there is a true value investment with biosecurity. It's really hard to see the return. It's hard to calculate. It's hard to know, was I just lucky that I didn't get this disease, or did what I do prevent it? Really tough to quantify. So why do we want to stop moving diseases? We've kind of talked about this, but in addition to the things I just talked about, you and I are very interested in the well-being of our animals, and especially as a veterinarian, as producers, we want them to be healthy and well. We want to minimize diseases and death losses, and we want to minimize the amount of work required to treat those diseases. Although PED does not fall in this category, there are also some swine diseases that do affect food safety, and we want to always be conscientious of that. So what is the cost of PRRS and PED? I want to just touch on this briefly. It's been estimated that PRRS costs the U.S. swine industry somewhere in the neighborhood of $560 to $660 million a year. That's a lot of money. That's an M, a capital M, $1 million. So that's over approximately 5.7 million sows, according to the USDA in 2011. So, ironically or interestingly enough, both PRRS and PEDV cost in that same range of $150 to $225 per sow infected. So if you can think about based on that estimate that's out there, a 5,000 head sow unit might cost $1 million. So what's the cost of biosecurity? Some will say, I don't have time, biosecurity is too expensive. I'll tell you, some of these diseases are quite expensive. So how much effort and time and expense is worth even regaining 10 to 30% of what this disease will cost you? So this goes back, I guess I'll just skip this one, it should be in your slides, but talks about some of those things we just discussed. Biosecurity, where are you vulnerable? And here's really just a set of questions. I've included them in your slide set. I know a few slides were different, but these are in there. And they're more for you to think about, and they might be good discussion points for you and your veterinarian or your health professional. So, some of the key areas are animal movements, supplies, entering the facilities, semen, people movements, clearly, equipment and tools that are brought into our farm, feed. Feed has been suggested as a potential cause of spread of PED. I don't know that we've proven that definitively, but pests, rodents, birds, and insects cause risks. Mortality management. What I mean by that is how do we remove our dead? Are they rendered? How do we interact with that renderer that picks them up? Land application of manure. That can be a risk to ourselves and to our neighbors. Maintenance personnel. If you have an issue and call in somebody from outside your facility, what steps have they taken? So again, these just run through a bunch of questions. You can ask yourselves about wean pig trailers, coal shipments, replacement animals. What are the status of them? What's the testing? What routes did that transportation take to get here? I'm going to let you read through some of those. Supplies, where are we getting them from? Do we know that? Do they have a no return policy? Could they have been in someone else's farm before yours? How do I interact with that supply store that I go to? Who else was there that day and the day before? Do we enter supplies directly? Do we clean? Semen? What's their testing procedure? Do you know it? Do they test relative to PED and PRRS? How long since they've had a break? Is it a stable stud? And I won't go through all of these, but people movements. Who are we allowing within our farm and how do they move? How do I move? I'm just going to let you read through some of these so I can let you ask me some questions. What kind of tools and equipment do I bring in? Where were they last? Feed. I'll skip through the rest of these for you. Land application. Who are my neighbors? Who's applying? Who is doing the application? Is it me or is it a contract individual? Where have they been? Who are my maintenance personnel? When do they come? So biosecurity really is an investment in health and productivity and the financial well-being of your operation. If you don't see it that way, then you're going to have little incentive to progress from a biosecurity standpoint. And with the way PED is moving, you will also get to experience it firsthand. That doesn't mean that you don't, if you do the best you can to keep it out, that it won't somehow make it in. But it should reduce the incidence. Okay, so all these topics and those questions, I know I went through those quickly, but I really think that those are well worth the time to sit down with your veterinarian and your other suppliers of different things and go through and ask those questions. Understand the answers, make sure that you're comfortable with them and what's going on.